In this session, we're going to talk about Nerdio for Azure and the Servers module. You'll learn about the way administrative rights and connectivity works out of the box in the Nerdio environment, how to add new servers, the VDI golden image, autoscaling, and RDS collections. Enjoy the session.
Today, we're going to continue talking about the servers module in the NAP. The next thing I want to talk about, I think we spoke about this in the previous session, but I want to remind everyone the way that administrative rights and just connectivity works out of the box in a Nerdio environment. So first thing to remember is that this is a standard Windows environment where the customer or the partner has the ability to connect to each and every server as an administrator and configure them any way they see fit, make any changes they want to the permissions, allow access to anybody they want, etc. Okay, so it can be modified. However, it's important for everyone to understand what the defaults are. And the defaults are as follows. When the environment comes out of the box, every server has a local administrators group, as every VM machine does. And part of that local administrators group is a group called IT department users. We looked at it when we looked at the groups module. This group contains members, and these members become local administrators of every VM that's in the environment. The exception to this is DCL1, which is a domain controller, and DCL1 does not have the IT administrators group have access to that domain controller, because the domain controller is controlled by users who are members of the domain admins group, which is a domain group and not a local administrators group. So in order to make a user a domain administrator, which is what's needed to make any and all changes to the domain, a partner would go in and then designate any one of these existing users as a domain administrator. And you'll remember that there is a checkbox in this section right here for grant domain admin rights. Okay, so being a member of the IT department group makes a user be local administrator of every VM. Checking this box gives them higher level of permissions by making them a domain admin of not just a local administrator of all the VMs, but also a domain administrator of the whole environment. And also you'll remember there is this grant desktop local admins rights. In addition to the IT department group, there is a group called desktop admins or desktop local admins. It's a domain group that's hidden, and it is also a member of local administrator groups, but only on VMs that serve as desktop. So anything that's a WS 001, etc., and all the RDS session hosts. So checking this box for any one user will also place them into this desktop local admins group, which will be a local administrator of the individual desktop. So 3 tiers: domain administrator, IT department group, which makes them a local administrator of all VMs, or a desktop local administrator, which makes them an administrator of only the desktop VMs, but all of them, not just their own. All the desktop VMs become administrable by this particular user. Okay, let's talk about adding servers. So we looked at all of the actions, what the servers look like, the different icons and what they indicate, how to change sizes. The next thing we'll look at is adding a new server. Adding a new server is obviously very easy. You click on the add button either on top or the bottom, give server a name, select an operating system. These are the ones that we've decided to list. There are obviously others that could be deployed, but not from NAP. From NAP, you can deploy these 5. If you select a Windows operating system, you do not get a prompt for an admin account, a local admin username and password. The reason is this machine will be added into the domain. So it will automatically join the domain. So any users that are either local administrators through the IT department group or domain administrators through the checkbox are going to be able to have full control of this newly created server. You then get to choose after the operating system, you choose your disk type, and then you choose your OS instance. And then we didn't talk about on-ramp regions, but if you want to deploy a server in another region that you've pre-configured through the on-ramp region module, you just check this box and select one of the on-ramp regions. Otherwise, if you don't select it, which is the default setting, it is going to be placed in the primary region. So in this case, it's a South Central deployed environment with an on-ramp region in East US 2. You can check the box, and then it will be placed there. Okay, and then it will be connected via site-to-site VPN tunnel to the rest of the environment. So that is how you add a Windows server. To add a Linux server, because it doesn't get joined to the domain, you get a prompt for a username and password that is going to be set as the local, the root user on the newly created machine. So this you do get to specify. And again, you can choose your storage and choose your VM type and choose your location. If you're operating in a hybrid AD environment, recall there would be an Active Directory dropdown with the hybrid AD or with the external AD being listed by default, being selected by default. So that would be another selector box if hybrid AD was enabled. And also the important thing I wanted to talk about next is how do you move a server that you add from the LAN to the DMZ. So by default, the server will be placed on the LAN and joined to the domain, so you can log into it as an administrator. However, sometimes you want that server to go to the DMZ. Now, it's really easy to make that change. You simply go to Manage IP, you change your DMZ from LAN to DMZ and set your IP address if you need to. However, because you only have a domain authentication credentials, once it goes in the DMZ, it will not be able to communicate with DC01 on the LAN, and authentication will fail. So before making this change, you need to log into the server first, add a local administrator account, and disjoin the server from the domain in order for it to be standalone VM, and only then you should move it to the DMZ. Once you move it to the DMZ, you'll be able to RDP into it from the LAN. So all connectivity from LAN to DMZ is allowed. You will not be able to use this button here because this button routes you through the RD gateway, and RD gateway only routes traffic to the LAN. It doesn't route traffic to the DMZ. So the way to get into a Windows server in the DMZ is either connect to a server on the LAN and RDP from there, use a remote connect tool, part of the RMM, like TeamViewer or whatever you're using. Or third option is publish create a firewall rule to the newly created server on the DMZ, set up a public IP address, and allow certain locations to connect to it. Obviously, that's the least secure one because that's not going to be an encrypted connection. So we talked about adding servers. Let's cover a few easy items here. So recall there is this WS00 golden image. We power it on, we generate an RDP file, we log into it, make whatever changes we need to make. We come back in here, power it off and set as golden. And then from this point forward, any VMs that get created and have a VDI machine specified, they're going to be a clone of this. Or any user whose desktop you revert. So if you were to go and do a revert desktop, it would then clone that particular VM. It would respect and remember the size that you used to have. So it would create a new VM with the same name, but the disk image that is going to be booted up is going to be whatever golden image is, whatever state it's at right now. If the golden image is powered on and you go ahead and create a user or try to revert to desktop, you will get an error message. And if you mouse over the error message, there'll be a tooltip indicating that the golden image is on and needs to be powered off for that operation to take place. So you have to resubmit that request. Okay, so that's your golden image. It is shutting down right now, which is why we have this strange message here. It should update in a couple of minutes. All right, the next thing I want to cover is autoscale. Okay, so we talked about autoscale conceptually, and we explained that the way that we manage autoscale is by leveraging Azure Automation, which is a service, a PaaS service that runs in Azure. And we have a system by which we submit tags to the servers that run, to the VMs that run in Azure. And then we enable automation with a custom script that analyzes those tags on an hourly basis and makes decisions as to what the server should do, how it should behave, whether it should be turned on, turned off, resized, etc. So why is that important? Why am I making an emphasis on how it works on the back end. What's really important about Autoscale is that there are two ways to implement it. One way to implement it is by having the NAP or whatever system is integrated with Azure doing all of the controlling. So we could have very easily had a scheduler built into the NAP, create a schedule for a particular VM, and then rely on the NAP to go into Azure and make the changes on a scheduled basis, right? That could have been a way it was designed. We chose very explicitly not to do it that way because we have a philosophy in the way that the NAP is designed is that it should always be not in the critical path of the usability of the system, meaning it's a provisioning, management, and optimization. But if for whatever reason someone decides to disconnect their environment from Nerdio or for whatever reason Nerdio loses access to the subscription, we don't leave things in an inconsistent state. So imagine a situation where you have a customer that has all of their VMs being shut off and having to be turned on at 7 a.m. And for whatever reason at 7 a.m., Nerdio isn't available or isn't able to connect and make those power on commands to all of the servers that rely on that schedule. What's going to happen? Users are going to come in at 7 and all of the servers will be off. And it's not like after it becomes 7:30, things are going to power on by themselves. They won't. So there's going to be a lot of manual remediation that will have to go in place in case of a situation like that. So we've designed Autoscale to be completely independent. Nerdio, the NAP specifically, just submits the schedule and the instructions, and then everything required to execute and act upon those instructions runs independently in Azure using Azure Automation. All right, the way auto scheduling works for servers, right? So we have this auto scaling for servers. This is the feature we're looking at right now. It's actually pretty intuitive. What you do is you define what we call work days and work hours. So we can say, let's say Monday through Friday, let's say 6 a.m. to whatever, 6 p.m. So we have a 12-hour work hour window, 5 days a week. You define the time zone that's relevant to that server, because obviously 6 a.m. to 6 p.m. could have different meanings to people in different time zones. So it's important to be explicit about it. And then there is an action, right? So days, hours, time zone, and action. And the actions consist of no change, means nothing is going to happen to that server. Power off, which obviously will power that server on, powered off, and then powered on during work hours. So meaning during work hours is going to be at this size, which is the one that's specified on the VM itself. And then off hours is going to be just shut down and then powered back on. Or you can actually resize the VM either within its own current series or even into a different series. So you can think of a situation where maybe you have a D instance during production with 8 or 16 or 32 cores, which is expensive. You set your hours and you say after hours, I want it to be a burstable instance with 2 cores and 8 gigs of RAM or whatever size you decide to use. When you click the confirm button, so let's go ahead and actually do this on another server. It looks like this one, a little icon like that next to the server size indicates that Autoscale is enabled. So we can go back to Autoscale, see what the settings are. So what you'll see is that once we submit the settings, so 8 a.m. to 6 p.m., Monday through Friday, and the action, let's say we're actually going to increase it in size. And the reason D wasn't available is because it's an A series, which doesn't support some of the disks. Okay, so let's go to A, let's say 2 cores, let's say submit. Now this doesn't really make sense, as you can imagine, because during business hours, you'd imagine it will be bigger than during off hours, but it will get the point across. So what this is going to do now is it's going to submit a task in our management tasks that will edit the autoscale settings, and it will submit those autoscale settings to Azure. And the way it submits them to Azure is this submit autoscale schedule. It's a hidden task, or what we call an automated task that you don't see in the default log. So this gets submitted to Azure, and all that really means is each VM, you recall that each VM we looked at has a set of tags. So if we look at, let's just say whatever. I don't think any of these will have tags, but let's take a look. So there's this thing called tags, and you can create any name value pair. Well, there you go. So these are the kinds of tags that get created, and this indicates what happens. Actually, this is a good example. So here is DCO1, that is our template, and here's what happens to DCO1. At the baseline, it is a DS1 V2, which is the size that it's set to in NAP. Nothing happens on Friday. Nothing happens on Saturday, Thursday, Tuesday, or Wednesday. On Monday at 10 p.m., and this is with an offset of, I think it's in UTC, so it calculates, calculates all these times based on the time zone submitted in UTC. So on Monday at 10 p.m. UTC, this is going to be turned off. And then on Sunday at 4 a.m., it's going to get converted to this version, which is really the same as this tag, which means it's going to be powered on. And then 9 hours later, it will be powered off. So the reason this happens with this particular VM is we always want to keep it off because that's how it gets cloned. It can only be cloned when it's off. But on a Sunday morning, we want this to turn on and then stay on for 9 hours so any pending updates can be applied and then it will get turned off. So this is how the schedule is really submitted to the server. There's then an automation script that goes through. It knows what all these names means and it knows how to parse and interpret these values and it acts on these values accordingly. The next thing I want to show you are the RDSH servers. So these have a special option for cloning. I don't recall if we talked about it last time, so I'll talk about it briefly again if we did. If you click clone, this will allow you to create a copy of that VM. It's going to shut down the current one in order to make a clone of it. It will boot up the new one and the old one. It will rename it to the next sequential number. So if we are RDSH02 already, this is going to be RDSH03. And there's going to be a comment that's going to say it was copied from RDSH01. And here, just like when you add a new server, you can specify the location. You can do the same here. You can specify the region in which you want that VM to be provisioned. Okay, so this will be an identical clone of the server. It will have a unique description and a new name, new IP address, but everything else will be the same, the size and the disk, which can then be customized. And you can then install different applications and assign different users to it. So in our case here, we have a copy of this one. Let's go ahead and delete it. When you go to delete a server, you get prompted for this confirmation, and then you get prompted again. I'm going to make sure I'm in the right account, 5009, and I'm going to delete it. Okay, and you only get the option to delete that server if there are no users assigned to it. If there are users assigned to it, then the delete option is unavailable. So RDSH01 is also not available for deletion. So let's talk about RDS collections. We already went into this when we were talking about Azure scale sets way back when we did the Azure fundamentals piece. But let me review some of these items. So when you go, when you create a Nerdio environment, this section is empty. You do not have the RDS connection broker server listed. That doesn't exist. And you only have an RDSH01. That's how it starts out. If you want to create a collection, in order to use a collection, you need to have a connection broker. Remember, collection sits behind a connection broker. Users connect to the broker determines where to place you and then chooses a host from within the collection. So when you click Add Collection button, all you have to do is specify a name for that collection, or really a description, because the name will always be A, B, C, etc. And then you select your RDS host template. So if this is a brand new environment, you will have RDSH01 only, and it's going to create a collection that is going to contain hosts that are identical to the starting template that you're starting with. And again, here you have the option to place it in another region. And if you had hybrid AD, you would have the option of placing it in the other domain, and that would be the default option. When you create a collection, a few things happen. It takes quite a long time, about an hour for a collection to get created. The first thing that it does is it provisions a connection broker, because that didn't exist before. It configures it and does all of this, the magic behind the scenes to make that happen. It takes a copy of whatever template VM you selected. One prerequisite for creating a collection is making sure that RDSH 01 is powered on. I believe that is true only for the very first collection, but it may be true for subsequent ones as well. But definitely for the very first collection, when you create it the first time, this server has to be on. If it's not on, you'll get an error with a tooltip telling you that RDSH 01 needs to be on. Just has to do with the nuances of how RDS Collections in 2016, they must have a session host added into them in order to get created. Okay, so you create a collection, RDS Connection Broker 01 spins up, a new VM gets created, and that VM becomes a template for the collection. So it becomes independent of the session host you selected. It's a clone of it, but it becomes completely independent. And it becomes a template that could be managed independently of where it started. So it could have started from 01 or 02, but it becomes its own template. That template gets created as an image, and then that image serves as the foundation to the Azure scale set, which is used to provision the member host. So again, you have a connection broker number one, you have a clone of the session host that you've selected that becomes the template. That template gets converted to an image. That image serves as the basis of the scale set, the Azure scale set. And then those session hosts that become part of the collection are based on an image based on a template, which is a clone of a session host and is now independent of it.